All right, today we are pulling back the curtain on the secret weapon that lets game AIs think and win so ridiculously fast. It's a strategy called alpha-beta pruning. And trust me, it's the secret sauce that turns a simple program into a grandmaster.
So let's dive right in. You've probably been there, right? You're playing chess or checkers against a computer, you make what you think is a pretty decent move, and boom, it instantly fires back with a move that's just perfect. It leaves you wondering, how on earth did it think through all the possibilities that quickly? Well, that's exactly the question we're going to answer.
The whole story really starts with an algorithm called Minimax. And Minimax is kind of what it sounds like. It's the perfect player. It works by looking at every single possible move and every countermove to that move, and so on, to find the absolute best path forward. It's guaranteed not to lose if it can help it. But, and this is a huge but, it's also the slow player. I mean painfully slow. In a game like chess, telling it to check every single outcome would literally take longer than the age of the universe. So you've got this perfect strategy that's, well, basically useless in the real world.
To fix this, we need to introduce two key ideas. First up is alpha. You can think of alpha as being from our AI's perspective. It's the max player, always trying to maximize its score. So alpha represents the best, the highest score that our AI is absolutely guaranteed to get based on what it's seen so far. Think of it as the floor. It's the minimum good outcome it knows it can lock in.
And on the other side of the board, we have beta. Beta represents the opponent's best case scenario. The opponent is the min player, trying to minimize our AI score, right? So beta is the best, meaning the lowest score that the opponent can force on us. If alpha is the floor, beta is the ceiling that our opponent is trying to keep the score under.
Now here it is, the single most important part of this whole thing. If you only remember one thing, make it this golden rule. If alpha ever becomes greater than or equal to beta, we prune. We just snip that branch of possibilities and stop looking down it. That's it. This one simple check is the entire engine that makes this AI so incredibly fast.
Okay, theory is cool, but let's actually watch this thing work. Here's a super simple game tree. We're the max player up at the top, and our goal is to pick a path that leads to the highest possible number at the end. Down below is the min player, our opponent, who's going to be working against us, always trying to push the outcome to the lowest number they can.
Okay, so the AI begins its search. It dives all the way down the first branch on the left and sees a final score of 3. Since this is the very first thing it's looked at, it sets its alpha value to 3. It's basically thinking, all right, I know for a fact I can get at least a score of 3 right now. That's our floor.
So, with an alpha of 3 safely in its pocket, the AI moves on to explore the next major branch of the tree. Down this new path, it's the opponent's turn to make a move. The AI looks ahead and sees that one of the opponent's choices could lead to a final score of 5.
But hold on, here comes the critical moment. On that very same branch, the opponent has another choice, one that leads to a score of 2. Now remember, the opponent is the min player. They will always choose the path with the lower score to mess with us. So they are absolutely going to pick the path to 2. This means, for this entire section of the game, our opponent can guarantee the score will be no higher than 2, and that sets our beta value to 2.
Okay, time to pause and apply our golden rule. The AI has its alpha value of 3 from that first path it explored. And on this new path, it knows the opponent can force a beta of 2. So we ask the all-important question, is alpha, which is 3, greater than or equal to beta, which is 2?
And the answer is a huge yes, it is. So what happens? We prune, snip. We stop looking at this branch entirely. Why? Because the AI already knows it has a move that guarantees it a score of at least 3. Why would it waste a single nanosecond more exploring a path that it knows the opponent can force down to a score of 2? It's a dead end. There's just no reason to go any further.
And that is the magic of this whole process. By making these smart little cuts, the AI avoids a massive number of pointless calculations. Now imagine this on a real game tree with millions or even billions of possibilities. This isn't just saving a bit of time, it's the difference between finding a move in under a second versus 100 years. So, to put it all together in one simple idea, alpha-beta pruning is just a much smarter and faster way of getting the exact same result as the original slow Minimax algorithm. It's like having a perfect roadmap, but also knowing all the shortcuts to avoid the traffic jams.
And that's so crucial to understand. This incredible speed doesn't come with a catch. It doesn't sacrifice quality for quickness.
The algorithm is built in such a way that the final move it chooses is guaranteed to be the exact same optimal move that the slow brute force Minimax would have found eventually. You get all the perfection with none of the waiting.
When you boil it down, the core idea here is just so powerful. Figure out what your guaranteed good outcome is, and then ruthlessly eliminate any options that you already know will be worse. It kind of makes you think, right? Where else in our lives could we solve complex problems a whole lot faster just by doing a little smart pruning of our own? It's a powerful way to think, for an AI and for us.